Hey everyone, my name is Jacques Ilunga and I'm part of Group 5 of the Junior Design class, otherwise called the Custodians. Today I'll be demonstrating the magnetic plate subsystem for our automated scrap metal sorting system. So let me show you here where the subsystem fits in our overall system. Here's our interface block diagram, and the magnetic plate subsystem is located here. It receives 12 volts power from the relay module and is controlled by the Arduino. Its output goes to the magnetic scrap bin, where it holds and releases magnetic materials. So what does this subsystem actually do? The magnetic plate acts as the end effector for our sorting system. When energized, it picks up magnetic metals like steel and iron. When de-energized, it releases them into the magnetic scrap bin. It's basically the hands of our sorting mechanism. This subsystem mainly consists of three main components: two UXL 250 Newton solenoid electromagnets, like these. These are the workhorses that provide the holding force. A steel backing plate that concentrates and directs the magnetic field. And third, a custom magnetic plate holder that mounts to our robotic arm. The complete assembly weighs about 1 kilogram. The electromagnets sit in these slots, and the steel backing plate, which is made from plain steel, sits on top and is secured with screws, bolts, and washers. Now, let me explain our test procedure. Now, let me explain our testing procedure. We have three key tests to validate our subsystem. First, electrical verification. We need to make sure that with 12 volts, the operational voltage of these magnets, they each draw about 500 to 600 or 650 milliamps each, which is specified in the data sheets of these electromagnets. Second, holding force test. We verify that the magnet can reliably hold at least 250 grams of magnetic material. And third, release verification. We confirm that when power is removed, the magnetic field dissipates completely and material drops cleanly into the bin without sticking. Per our design, our system should be able to pull 2 pounds per minute, and the scrap that we will be using for further testing would be this steel plate cut up in smaller pieces. This steel plate weighs around 430 grams. That is about 0.9 pounds, or 98 pounds, so almost 0.62 milliamps. You can increase the voltage a little bit to have it be at 12, which is its operating voltage. So now we have the two magnets activated and the steel plate now magnetized. And if I dispose of this steel plate like this, the steel plate is picked up, and ultimately we would want that after it is done picking up the scrap, we deactivate the magnet and it falls. So as you saw in the previous video, all three testing criteria were validated. First, electrical testing. Both magnets used about 12 volts and pulled around 0.6 to 0.7 amps. 2, force testing. The magnetic plate was able to pull a steel plate weighing about 1 pound with ease. 3, release. When power was cut from the system, the magnetic plate was able to instantly release like scrap.